All right, 6-6. We just got done doing derivatives and antiderivatives of natural logs. Now we're going to be doing the derivative of logs that are not base e. And we're going to do that by using the change of base to turn them back into log base e. So remember, the natural log is just the log base e. So when we have log base e, we give it ln so it doesn't get confused with log base 10, just notation. And remember, the natural log base e of e would simplify to 1, and you would see that if you did your switch it to the exponential form, wherever that's at, right here. But we're not going to take the time to do that. All right, so we're going to be taking logs that are not base e, so log base b of x. We're going to rewrite them with the change of base property. And when we change the base, we're going to go into the natural logs because we know how to do derivatives of natural logs. Okay, I've got an a as the base here, but that's okay. So it's the natural log of this divided by the natural log of the base. So all of these are going to get converted to natural log of x divided by the natural log of the base. And we're going to know that number. This is going to be a number under here, a constant. So what I'd like you to do is take the time to rewrite that as slide this ln of x off to the side and leave a 1 in its place. So you have 1 over ln of b times the ln of x. This right here, and this was the part you were struggling with, this will always be a constant value. This will represent a number. There is no x's in it, no variable of any kind. That's a constant. And it's a constant multiplier, so it will carry along. The only thing we have to do the derivative of is over here, and we carry this along as a multiplier. So it's a constant multiplier. So if you want to skip over this middle step, that would be fine, but you do have to take the time to rewrite it. So I'm going to be skipping over this because I know you guys are going to do, and it's just practice now. So here we go. Find the derivative. And I got, I don't know how many, 5 or 6 examples here. So find the derivative. We got y equals log base 2 of x. Okay, the only logs we can find derivative of are natural logs, so we're going to use that change of base to rewrite it. So it would be natural log of x over natural log of 2. I'm going to make it 1 over natural log of 2 times natural log of x. So I'm pulling that natural log of x off to the side. I can see this is a multiplier, so I'm ready for derivative. Multipliers carry along. So I carry along the 1 over ln of 2. And then derivative here, derivative of a natural log is 1 over u times u prime. Derivative of x is a 1. And then just so you're not confused, we wouldn't write this as natural log of 2 times x because you might think it's the natural log of 2x. This x is going to come in front. So it would be 1 over, float that to the front. Now there's no confusion that the natural log is only of 2 and not 2x. Done. Another one. Y equals log base 4 of sine x. So again, you have to rewrite it into natural logs. So it would be natural log of sine x divided by natural log of 4. Again, pull it out in front, 1 over natural log of 4, multiplied by the natural log of sine x. So again, only x is over here. This multiplier, this fraction, that's a constant. It just carries along. It doesn't change. Multipliers carry along. So derivative, keep the multiplier. Now we're ready for derivative. So this becomes 1 over sine x. So 1 over u, and then u prime is cosine x. Keeping my fraction bars lined up, I can see I've got cosine over sine, and at this point of the year, should be no problem seeing that as cotangent. So I would have cotangent x over ln of 4. As the derivative. Okay, number 3. G of x equals 4 log base e of x to the 10th. Well, take a look at what I did here, or the author's going to do it to you. Log base e, that's just the unconventional way to say ln. So this, I don't have to use the change of base. It's already in base e. So I'm not doing derivative yet. I'm just going to swap that out for 4 ln of x to the 10th. And now at this point, I can jump into derivative now, or I can bring that exponent down first, then do derivative. Just don't break any rules. I'm going to bring the 10 down first, so it would be 40 ln of x, and now I'll do derivative. So see how the notation helps me keep track of where I'm at? I don't put derivative notation until I'm actually doing the derivative. So it's going to be 40 times 1 over x, or just 40 over x. Easy one. Okay, number 4. This time I've got m of x equals log base 4 of x divided by log base 2 of x. Okay, this is not one of our log properties. Remember, that's the misconception. Nowhere do we have a log divided by a log. Nowhere. We've got a log of a quotient, but not log divided by log, so I can't do anything with that. So I need to do change of base in the top and the bottom. So the top becomes the ln of x over ln of 4, or I'll make it 1 over ln of 4 times by the ln of x. Then that's going to be over. This is going to be 1 over, ln of x over ln of 2. So 1 over ln of 2 times ln of x. And you can see in my fraction, the ln of x's end up canceling each other out. I have not done derivative yet, but now I'm ready for derivative. And if I flip and multiply, I'm going to have, I'm not quite ready, if I flip and multiply, I'll have ln of 2 over ln of 4. Oops, over ln of 4. And if you look in here, there's no x's in there. So when I go to do derivative, this is just a constant. A constant divided by a constant gives me a constant. So my derivative is just going to be 0. The x canceled out. Derivative of constant, 0. Okay. Next one. Number 5. We're going to find and evaluate the derivative and compare with n derivative. So compare derivative with n deriv. So we're going to calculate it exactly, and then we'll use the n deriv and see how close the two values are. So we'll start with y equals log base 3 of x And we want to find the y prime at 10. Okay, so we're going to want the derivative value at 10. So before we can do derivative, we've got to rewrite it. So it'll be ln of x over ln of 3, or 1 over ln of 3 times ln of x. Derivative now. Constant multiplier carries. Derivative of ln of x is 1 over x. And we want to plug in a 10. So the y prime at 10 will be 1 over, I'm going to bring the 10 to the front, 10 ln of 3. So if I grab my calculator, I want 1 divided by 10 ln 3. Notice the parentheses to keep the 10 and the ln of 3 in the denominator. I get that. So 0.09102. All right, now if we go to end deriv, we do the deriv of the original problem, but I'm going to use it at the second line here. So math, end deriv, that's going to be an x. Equation is ln of x divided by ln of 3 at 10. And there it is. 0.9102392. It doesn't change to like this 9th decimal place. So end deriv's pretty good. All right, and then our last one is tangent line. Finding the equation of a tangent line. Coming back again.